Okay, so we've been talking about ways to evaluate classification models. We've talked about accuracy, precision, and recall. So in this video, we talk about F1 score, which is supposed to be a balance between precision and recall. Remember, precision and recall address two different issues. Precision are the instances that I've determined as positive, likely to be positive. Recall are the instances that are positive, that are out there, likely to have been classified as positive. So these are two different issues. You get two different measures, and let's do some comparisons here. Okay, so suppose we have three different classifiers, and let's look at some specific examples of three different classifiers. Here we have one where we have 60% precision, 40% recall. Here we have 12% precision, 98% recall, 95% precision, 5% recall. It's worth thinking about what these numbers actually mean. This one here, it has very high recall, which means that it's catching all the positives, but it's also catching a lot of non-positives. So you're casting out your net, you're getting a lot of fish, you're getting a lot of garbage in your net as well. Here, you have good precision, means the ones that you've identified, you have high confidence are positives, but you're only getting a small fraction of the positives. So you're throwing out your fishing line, you're likely to get a fish, but you're not going to get all the fish. This one here is sort of a balance. You're casting your net, you're getting a fair proportion of all of them, and you have a pretty good chance that if you have identified it as positive, it is actually positive. So this first one is sort of balanced. Now if we try to compare the three algorithms just by, say, taking the average of precision and recall, they come out to be about the same. This one comes slightly better. But if we want an algorithm that is more balanced, we should have some kind of measure that gives a better measure for the first one than for the other two. So a common choice is F1 score. Here's the formula: 2 times precision times recall over precision plus recall. This seems somewhat unmotivated. Let me give you some mathematical background to this formula. Now, for shorthand, I'm going to let precision be P and recall be R. So if you write this expression using these letters, 2PR over P plus R, if you divide the numerator and denominator by PR, you actually get this expression here. Now, what's 1 over precision? Well, precision is true positive over true positive plus false positive, right? What's 1 over recall? Well, recall is true positive over true positive plus false negative. So 1 over P plus 1 over R both have the same TP in the denominator. I can combine this fraction in this way. I multiply the top and the bottom by TP, and you end up with this expression. So the F1 score is actually this expression in terms of true positive, false positive, and false negative. And you see what's going on here. Instead of taking true positive over true positive plus false positive, which would be the precision, and instead of taking true positive over true positive plus false negative, which is the recall, you're basically taking the average of the false positive and the false negative. So it's kind of taking something in between. So I really prefer this representation of the F1 score. And you should notice that when they write the equation this way, they're doing precision and recall not in percentage, but in proportion. Right? So you would not put percentages into this formula, but proportions. But if we use this formula, we don't have to worry about percentage or proportion. We just use the true positives false positives, false negatives. All right? So I'm going to use this formula to compute my F1 scores. Now you can verify this column based on these numbers. Actually, what I said earlier is incorrect. You can put the percentage values in here and get the correct F1 score. For instance, computing the F1 score for the first one, you have 2 times 60 times 40. That gives you 4,800. And then divided by 60 plus 40, that's 100. So you get 4,800 divided by 100 gives you 48. And for the second one, you do similar. 2 times 12 times 98 over 12 plus 98. You can work that out as 21. For the last one, 2 times 95 times 5, which gives me 950, divided by 95 plus 5. Well, that actually gives me 9.5. You can check this and see if this is correct. But that's how you would apply this formula to get F1 scores from these values. So again, the fact that the F1 score for the first one is higher reflects there's a better balance between precision and recall. It's not unbalanced, great recall, poor precision, or great precision, poor recall. Now, I think this graph can be helpful in showing the relationship between precision, recall, and F1 score. So here you see precision can be between 0 and 1. Recall can be between 0 and 1. And these contours show the F1 score. So the F1 score for any combination of precision and recall along this line is the same. So you can see here that here I have very high recall, poor precision, and that's giving me the same F1 score as here I have fair recall, fair precision. It becomes extreme down here. Here you've got very good recall, very poor precision, but a very low F1 score. It's better to have a balance of really mediocre recall and precision, and that gives me the same F1 score. Right. So F1 score is favoring the balance between precision and recall. Right. This balanced point here has the same recall as has the same F1 score as either this point or this point. Now, of course, to get perfect F1 score, both precision and recall have to be perfect. If either one of the precision or recall is 0, the F1 score is 0. You can see that here in the graph that despite the very good recall, if the precision is close to 0, the F1 score is going to be close to 0. So there's no cheating. You have to perform at least to some extent in both precision and recall. All right, so let's do some computations of F1 scores in particular examples. Using the harmonic mean formula, you can work this out as 40.6%. In fact, if we use my formula, which is true positive over true positive plus false positive plus false negative over 2, that's going to be 75 over 75 plus, now false positive plus false negative over 2 is the average of these two numbers, 20 and 200, which is 110. And you can work out that this also gives me this is going to give me 0.405, which converts to 40.6%. So you can do the F1 score either way. Similarly, we have this harmonic mean formula. You get 20.5%. If I do it the other way, you get 150 over 150 plus the average of these two numbers is 1160 over 2, whatever that is. And you can work out that that also gives you 0.205, which is going to give you 20.5%. So to get a percentage, you'd multiply that by 100. So you can also compute the F1 score that way. So in general, you will be trying different models for classification and comparing. So you train all of them and you compare the accuracy, precision, and recall and F1 score on cross-validation and pick the one with the highest F1 score. So that would be the model that you actually use. And then you'd compute the accuracy, precision, recall, and F1 score on the test set, and you'd quote this as the performance of this approach. Now here I said that you use F1 score as selection. There might be cases where you don't use F1 score. So it's really up to you to understand the application, understand which of these measures is important in your classifier, and use that measure as a selection criterion. Okay, this finishes our discussion of classification measures. In the next video, we'll move on to issues that are encountered in designing classifiers, in particular overfitting and underfitting. Thanks for watching.